Hello farmers, and welcome again to the Kenyan Farmer. As a farmer, you will be required to measure many things at the farm. One of the confusing things you may have to encounter is the various units used. There are standard units that are internationally accepted, but let's face it, you have no control over what scale the tool manufacturer uses. The scale used on various tools may not be as obvious to many farmers. You will find a disconnect between old school farmers and new farmers when it comes to taking measurements. My parents used feet while measuring distance, but I was taught to use meters. I think a Kenyan farmer should learn how to convert between the various units so that your life will be less hectic. And so, this video, I want to show you how to deal with various units. Generally, there are two systems used in measurements. Metric system is the most common and widely accepted in many countries. We also have imperial system that is less common but still appearing here and there. Sometimes farmers will use both systems unknowingly in their day-to-day life. Like most Kenyans will express land area in hectares or acres. Well, nowadays there is uncontrolled subdivision of land into tiny portions, something very frustrating to farmers, but good for real estates. Luckily, some units cut across metric and imperial system, like measurements of time, in seconds, minutes, hours, days, and the like. Now, there are various tools that I use at the farm. The basic tool that I believe every person is conversant with is the ruler. If you understand it, you can use it as a basic unit when doing conversions within a reasonable estimate at the farm. You will understand this as we get deeper into the video. At times, you will use a tape measure, or rather, a measuring tape, which also has a scale indicated in both meters and feet. If you have ever bought timber, then you know how those hardware guys like to use feet. A bit confusing. For those who like to buy small plots of land, then they are measured in feet. However, land surveyors may choose to use longer tapes when measuring land. Although nowadays, some of these survey activities are slowly going to digital using GPS and other fancy tools. This meter, I will not talk much about it, but if you need to measure pH, concentration, and electrical conductivity or EC in water, then you may need to use it. And this is a pressure gauge. It may not be common to many farmers, but if you are doing some form of drip irrigation, you may need it. As you can see, the scale is in both bars and PSI. We will talk more about pressure at the end of the video. So, back to the first tool that I started with, a ruler. I did mention that this is what I use in conversion of most units, especially when dealing with length. What do we know about a ruler? One ruler is 1 foot. From the scale, we also see that a ruler is approximately 30 centimeters, which is about 12 inches in length. That information is enough for most calculations for now. Oh, and we know 1 meter is 100 centimeters. Our first question is, now that we have this information, how many centimeters are in an inch? From the ruler data we collected, we know that 12 inches is like 30 centimeters. So, what about 1 inch? We do cross multiplication and get 2.5 centimeters. That's close enough. And now we also know that an inch is approximately 2.5 centimeters. Nice. Okay. What if you need to convert a meter to feet? From the ruler data, we know that 30 centimeters is 1 foot. What about the 100 centimeters in 1 meter? You get approximately 3.3 feet. And let's say you have 50 feet that you want to convert to meters. From the ruler, we know that 1 foot is 30 centimeters. So, what about 50 feet? You do the cross multiplication and get 1500 centimeters. To convert this to meters, we divide by the 100 centimeters in a meter. And then you have 15 meters. So when those marketers are talking about 50 by 100 piece of land, you have an idea how small that is. Another example. In my previous video on drip irrigation, I measured the pressure and got about 5 psi. And I'm wondering if I can estimate the height of water in feet. But before we do that, let me first explain what I understand by pounds per square inch unit. Let's assume you have an area at the bottom of a tank that is 1 inch by 1 inch square. We also imagine that you have a column of water resting on that area only. The height of the column of water is 1 foot. The weight of that water at the base will be approximately 0.43 pounds. I hope that explains that 1 foot is approximately 0.43 psi. And by now, you should see the relationship between the height and the pressure. One thing that may be confusing to farmers is that it doesn't matter the volume of water. It may be even the entire Lake Victoria. As long as it's 1 foot deep, the pressure at the square inch at the bottom is still the same. Note that we are not changing our reference area at the base. It is still the 1 square inch. All the other information is just to mess with your head. I know PSI is not a metric system, but as I said earlier, you can't control the choice of the scale that the manufacturer uses. It's a pity. You just have to adapt. Actually, the most acceptable unit is a bar. But then again, 1 bar is very big when dealing with average pressure on most gravity-fed systems in Kenyan farms. If you are using pumps, then that's a different case. Anyway, I'm getting away. We want to know how high the water level is in feet. How so? From the ruler data, we know that a ruler or 1 foot of water column is approximately 0.43 psi. And so, what about the 5 psi that we measured on the gauge? After you do the cross multiplication, you'll get 11.6 feet. So, when my old school uncle says that we have or the pressure head is 11 feet, then I can now wrap my mind around the idea. Cross multiplication will work for most of the farm calculations. And now we go a notch higher. In my previous video on drip irrigation, I did demonstrate how I estimate flow rate of the main line. I filled a bucket of 20 liters in 26 seconds. Can I express this in liters per second? Yes, simple. You can see it's just 20 liters divided by 26 seconds to get 0.769 liters per second. So let's express this in liters per minute. We know that 1 minute is approximately 60 seconds. So we first draw lines like this to separate the figures. Then we write the figures that we have on the first column. On the second column, I write the conversion ratio. 1 minute is 60 seconds, but how I write it matters. I write 60 seconds on top so that the second units can cancel. The units we are left with is what we are looking for, liters per minute, and so we are on track. With this method, you multiply figures directly. You don't flip them around like in cross multiplication, and so you get 46 liters per minute. So let's assume you wanted to know in milliliters per second. And of course we know 1 liter is approximately 1000 milliliters. We draw the lines and put the figures that we have. Now, the next figures we are going to input must be arranged in a way that what we don't want cancels out. We know that 1 minute is 60 seconds. So this time I'll put minutes on top and 60 seconds at the bottom to get rid of the minutes. We also know that 1 liter is 1000 milliliters. We also write these figures, but still in a way to cancel out what we don't want. It's plain to see that we have been left with mils per second. That's what we want. After multiplication, we get 766 mils per second. Please note, in this method, we don't flip around the figures. We just multiply directly. The more you practice this method, the more you will fall in love with it. I'm sorry, I'm starting to sound like that math teacher who could talk about complicated formulas being the most beautiful thing since Kenya got independence. I mean, beauty and maths in my brain, they were in different lanes. To me, I was like, anyway, it is what it is. As a farmer, you have to somehow adapt and survive, or hire someone to help you out. Thank you for watching. Remember to like, share and subscribe. See you in the next video, and God bless you.